video, I'll be doing a random online assessment set from a company. Uh, it does show that I've finished everything, but uh, it's been a while, so I don't really remember stuff from here. So let's just see. So let's start the mock assignment and let's just get going. Given a string S, return the longest palindromic substring in S. Okay, so it is a substring and it's just 1000, so we can just brute force. For I in range 1 to len of S, we can just have one if len of S equals 1, return 1. And here we can just do for j in range I, and we can just get the sub, which will be S from uh, actually yeah, no, we can just do sub equals this. J if sub equals I think this is how you reverse a string in Python. Then we can just do max len equals, and what do we want? Oh yeah, no, we want to do it for every j. Yeah. I'm sorry, I messed that up a little bit. So we're gonna start at I minus 1 and then we wanna go to -1 and if sub equals sub of this, then we can just do max L equals max of max L, comma, and we want to do I minus j. So if it was like a 2 and then j was at 1, then 2 minus 1 would be 1 plus 1. So we want to do that, and then we just want to return the max L. So this hopefully should work. I'm not entirely sure, but let's just see. Oh damn it, we actually want to return the string. Oh my god, I'm kind of an idiot. ENS equals that. So L equals R I minus j plus 1 if L is greater than max L. You can just get rid of this. Then we can just set max L equals L and answer is equal to the substring, and we can just return answer. This should be okay, and answer initially is just going to be S of 0. BAB. Oops, I submitted that again by mistake. We can run code now. I think there might be a quicker implementation to this. Oops. Oh, expected A, output 1. What? How is output 1? Oh my god. S of 0. I am such an idiot. Actually, I don't know if this will pass. What the hell? I minus 1 to 1. Oh yeah. It should be like that. Why am I making such mistakes? If this doesn't work, I'll move on to the next problem. Yeah. Okay, cool. That's good. Let's go to the next unsolved question. Given an array of points where points I, x, I, y, I represents a point on the xy plane and an integer k, return the k closest points to the origin 0, 0. And you want to minimize the Euclidean distance, so that's that one. You may return in any order. So if it's that, so you have that and k. k closest points. Turn k closest points to the origin. Oh, okay. So you just wanna. Oh, wait. So you just calculate the distance of each point to the origin, and then you just store it, and then just sort it. Yeah, that works. Okay. Uh, that's good, and we can just get dist equals just for I in range. We can just do dist dot append points I 0 square and plus points I 1 square, and I'll just put that in a bracket because even though I know how the computer spot masters work, but still. And okay, uh, dict uh, dist d, d and for I in range len of points. Uh, wait, are all of these points unique? Return. I'm assuming these points are going to be unique, so that should be they should uh, that should work. This d points I equals to dist I, and then we can just do dist d dot sort. Oh wait, how to sort a dictionary in Python? I don't know how to do that. I just genuinely do not remember. Uh, by Yeah, we are sorting by value, right? By value. We can't sort it by key. We gotta sort it by value. There we go. So that should hopefully be sorted. And now we just want to return the top k. So for I in range k, actually let's do for I equals 0, for k we in list d dot items ans dot append k I plus equals 1 if I is less than k. Let's make, so let's run this. We might need a default dict here. Yeah. uh, how to make a default dict hash map in Python. I do not remember how this stuff. I kind of forgot all of that. I don't know how. How to store a list as a dictionary key in Python. Oh, okay. So you can just store it as a tuple. So we can just store it as a tuple. I think it's because you gotta make sure uh, this stuff is not mutable. I think that's pretty much the reason. So we can run code now. Int and tuple. Oh yeah, damn it. If I is less than, oh yeah, let's do key. Yeah, we sort of reused a variable there. Don't know why we did that, but I mean, as long as we aren't submitting the code and getting the wrong output. Let's just use example test cases and run it on that. Because I don't want to submit anything wrong, because if I submit anything wrong, then it's just not that great. This seems to be correct, so we can just submit. All right. Wrong answer. God damn it. Output 1 1 2 2 2 minus 2 2 2 2 2. Oh, so you can have multiple same inputs. That sucks. Wait, but I don't get it. Like, why can't you just have. Oh, cause. Okay, got it. So my thing wasn't working there. That just sucks. So if I have the distances now, basically I wanna sort. I can just zip these together. So we can do dist equals. We can just call it like final equals dist zip points disks, and how to sort a multi-dim list by its first element. Let's set. So we want to sort final, and then we just want to do what are we sorting in? Yeah, we are sorting in that way. So for I in range k ans dot append final I 0 return ans. That should work. If this doesn't work, then I genuinely don't know what I can do to make this stuff work. I think this works. Let's submit. It took us much longer than what I would have wanted, considering the fact that both of these questions were very, very easy. Oh, they weren't easy, but whatever. I really thought that these were both very easy questions. Okay, so let's just wait for the score report to be generated. I mean, this one was just like a implementation problem, and I think this one would have come down to just optimizing, and I think there was probably some sort of a OFN approach to this. I can't think of an OFN approach to, like, there probably would be, but I just wait. Let's see. Uh, so min heap means it's gonna be n log n. Yeah, so everyone has used like heaps and priority queues and stuff. So everyone's uh, done the stuff in like a n log n time only. No one's done this in OFN. So that's good. Uh, I'm 100% sure longest palindromic substring can be done quicker. Uh, I'm not sure. Wait, let's just go ahead and copy this code for the second one and submit. And let's see what we get. So we beat 88%, and we are also doing well in memory. So let's just look at some of these faster ones, and they are pretty much doing the exact same thing. It's just that they are doing it in like one thing, and we have like two things being made here. But it's nothing too crazy. Like, it's all pretty much the same stuff. But yeah. And what about these guys? Like, what do these guys do? Yeah, it's pretty much just the same stuff. It's not that deep. Okay, cool. So even in terms of space, I'm guessing that that's gotta be the only thing. Why is this taking less space? I don't know. But whatever. We are, so this means we got this solution in optimal time complexity and optimal like pretty much optimal space complexity. Uh, so let's copy the code. I'm 100% sure we did not get this thing in optimal time complexity. I'm sure there is gonna be a DP solution to this, but for now, let's just see uh, if that works, if this works. Yeah, like I said, we are doing well in memory, but that doesn't matter because we are not in the optimal space complexity. But the only reason why I did this was one, because we were in a bit of a time crunch, and I mean, the constraints allow you to do that. That's pretty important. Like, that's something that makes a lot of difference to me. Uh, as far as I know, the simple way that these guys actually do it is that there's some sort of a two pointers plus DP solution to this. I'm just gonna go ahead and take a look at this. So this is what we did. This is what we did over here, and then this was the DP that I was talking about. That probably would be. So DP of ij is a boolean representing if substring inclusive with bounds ij is a palindrome. We initialize dp of I equals true for all substrings of length 1, and then dp of I plus 1 is equal to s of. Okay, that makes up a lot of sense. So this just gives you an O of n square. This was the one, this is like the approach I have personally seen people do. And then there's like these Manishers approaches that is like ridiculously complex. Like, no one expects you to know Manishers for this. So I'm not really gonna. I'm not really gonna, because I've seen this problem in like one of my university's ICPC qualifiers. So like I was like, I know you can do this in offhand using managers, but I'm like, I do not know what managers is. Like, I have never used it, so no way I'm actually gonna be gonna like work on that. And plus, if I'm getting good constraints of like just 1000, why on earth should I just not exploit those? Like, why? If there's anything I've learned from code forces, just exploit the conditions you have in terms of time. So whatever. So that's it for this video, and I hope you enjoyed it. And you can kind of see how we did a bit of an analysis of the interview. We didn't really perform that well. Like, I probably would have wanted to perform much better than what we did. 6.61 is not optimal. I'd probably want to be in this or this. Uh, like either of these, but it's all right. Like, part of the reason why, I think it's just that the time spent was something that we did quick, but it just took us like a lot of wrong attempts, especially to get the first one. Like, I don't know if we can see all the wrong attempts. No, we can only see this. So whatever, so as you can see, we made like some very stupid errors, like these bounds, and just some very stupid stuff that took up a lot of attempts and just took up a lot of time as well. And I think we can, you know if we be careful, we can easily get this thing down to like 9 minutes, and that would be pretty optimal. Although, I mean, making errors is part of the whole thing, and from all the online assessments I have given, errors are generally not penalized. Like, they don't care if you make like 50 errors, but as long as you submit the correct code that passes all test cases, that's like the main thing. So, like, yeah, as long as you can do that, that's good. So that is that, and we are done for this video. So that's it for this one. Hope you enjoyed it. If you did, like and subscribe, and I'll see you in the next one. Bye bye.